Problem 13, part B, final exam practice. We want to find the radius and interval of convergence for this power series. So starting at n equals 1, going to infinity, terms look like 4 to the power n, x minus 1 to the power 2n, divided by n squared. And so our an's here, these are just the nth, this is just the nth term of our series. This is going to be 4 to the power n times x minus 1 to the power 2n divided by n squared. And so we're going to use the ratio test to determine the radius of convergence here. So we'll look at our ratio test. Want to look at the ratio of the n plus first term to the nth term in absolute value. And so in this case, we're going to write out a sub n plus 1. This is 4 to the power n plus 1 times x minus 1 to the power 2. So we're replacing n with n plus 1. So this would be 2 times the quantity n plus 1. And then divided by, again, n plus 1 quantity squared. Okay. And then divided by the nth term. So 4 to the power n, x minus 1 to the 2n divided by n squared. So simplifying a little bit, we have n plus 1 factors of 4 in the numerator, so we can cancel n of those with the n factors in the denominator. We have, so 2 times quantity n plus 1 is 2n plus 2, of course. And so we have 2n plus 2 factors of x minus 1 in the numerator, 2n factors in the denominator, so we can cancel all of those 2n factors. We're left with 2 factors in the numerator, and then we have the rest of the expression to figure out. So we have a 4 that can come out front. We have an x minus 1 squared that can come out front, which if you think about it, I don't need the absolute values here because I'm squaring the expression. But either way, the rest of the term is going to look like n squared in the numerator and n plus 1 squared in the denominator. And so I'll go ahead and multiply by 1 over n squared in the numerator and denominator. And so I'm going to get cancellation here, so just left with 1 in the numerator, and in the denominator I'll have 1 over 1 plus 1 over n to the power 2. And so we have n going to infinity. We want to evaluate this limit. So 1 plus 1 over n, so 1 over n goes to 0, of course. So the denominator goes to 1 squared. 1 squared is, of course, still 1. So this just goes to 4 times x minus 1 squared. And for this to be absolutely convergent, this needs to be less than 1 by our ratio test. Okay, so this tells us that the absolute value of x minus 1 squared, so I keep switching between absolute value and parentheses. I'll just keep absolute value because we're going to go back to it ultimately anyways. And so this is equal to, less than equal to 1 over 4, just dividing by 4 in this inequality here. And so now I want to take the square root, right? So that'll tell me something about the absolute value of x minus 1, which is exactly what I want to know about. This tells me about the radius of convergence. And so this is less than 1/2. And so also by our root test, or sorry, our ratio test rather, that we used here, if we have this expression is greater than 1, then we know that it diverges. That will actually turn into this absolute value of x minus 1 is greater than 1/2. And so this tells us that our radius is equal to 1/2. Okay, so now the question is, so we know the center, even though we weren't asked the center, it comes into play, and the center is equal to 1 here because it's this value we're subtracting off of x. So either way, so we know the center is equal to 1, we know the radius is 1/2, and so now we have this kind of diagram. So we have 1 here, we can go out to 3 over 2, that's adding a half to it. We can go out to minus 1/2, that's subtracting a half from it. And then the question is, does this series converge at either of these endpoints? So we'll test both of these endpoints. and this will determine the interval of convergence. So for x equals -1/2, we're just going to substitute -1/2 into the series. So it will look like so 4 to the power n -1 or -1/2 minus 1 to the power 2n divided by n squared. And this is equal to so in parentheses here we have 3 minus 3 over 2 to the power 2n. And so we can write this as, alright, so sorry about that. I actually realized I made a mistake. I subtracted 1/2 from 1 and I wrote -1/2, but of course that's not the actual value we were dealing with. It was 1/2. So I needed to change this -1/2 here into a +1/2, changes this one into a +1/2, and so now this expression will actually make sense. That's why I started to get a little bit confused there for a second. So either way, we're just going to simplify this numerator, and so it's equal to 1/2 minus 1 to the power 2n, and so this is just -1/2 to the power 2n. And so if you think about this, -1, so this minus sign here, this power is always even, right? It's 2 times n, so for any value of n, 2n is even, and so I'm looking at an even power of a negative number, so it'll come out as positive. So I don't even need to keep track of this minus sign, it just cancels out essentially. So I'm left with 1 over 4 to the power n. So I brought the square into this expression, so squaring 1/2 to get 1/4. So I have that to the power n, and the reason I want to write that is so I can get some cancellation in the numerator. Alright, and so I have 4 to the power n divided by 4 to the power n in the numerator, so I can just cancel this now. Leaves me with this p series with p equal to 2. Right, and 2 is certainly strictly greater than 1, and so this is a convergent series. And so our series does in fact converge at the value x equals 1/2, so we'll include that in our interval of convergence. And so now we just need to check if this series converges at x equals 3/2. So when we evaluate at 3/2, we get the series 4 to the power n times 3/2 minus 1 to the power 2n divided by n squared. So we need to simplify the numerator again, but you'll see that this is 1/2 to the power 2n. And so we're going to get 1/2 squared is 1/4, so this is just turning out to be 1/4 to the power n divided by n squared, so it's exactly the same thing as we had before, just comes out as the same p series with p equal to 2, which is also convergent, so we'll include both endpoints into our interval of convergence, and so our interval is going to look like this. So 1/2, +1/2 to 3/2, and we include both, so we put the square brackets. All right, and that finishes off problem 13b for us.